Hello. 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 Can you guys hear me? I'm just setting up my chat and then I'll start the stream. I'm going to be doing another derivative stream. Last time I did about optimization stuff. This time I'm also be going to do some more questions about optimization. And I will also do L'Hopital's rule. I don't know how you pronounce that name. Wait, let me change the title. Optimization problems, maybe. Okay, let me change to full screen. Alright, so I'm going to be doing calculus volume 1, derivatives. So last time I did, where is it? It was here, applied optimization problems. I'm going to be doing the exercises this stream. And then I'm going to do L'Hopital's rule, Newton's method, and anti-derivatives. Hopefully, like I'm planning to complete these three this stream. Hopefully I end up doing that. Okay, so first question. I want like a question. Not no pen. Also, the blue questions I have the answers. Just this is chapter 4. So you're moving into a new apartment and notice that there is a corner where the hallway narrows from 8 feet to 6 feet. What is the length of the longest item that can be carried horizontally around the corner? Also, let me check if my mouse is being recorded. Wait, I'll have to do it on OBS. Okay, it shows the mouse here. Copy. What does T mean? Then I'll drag this here. There's a corner. What is the length of the longest item that can be carried horizontally around the corner? So how can I solve this? Okay, this is a tough question. Uh, so we have to find the maximum length. No, we have to find the shortest length of L, right? Is the longest item that can be carried horizontally around the corner. Okay, so I'm not really sure of the answer, but I will try. Oops. Wait, I'll just do it here. I'll see. Let's take a blue one. So this is 8. This is 6. And then let's call this V and H. And actually, let's do it differently. Let's call this L1 and L2. So wait. VH. So mm, I actually have no idea how to do this. This is 6. This is 8. I need to find how much L changes. Notice there's a corner. What did they mean by carried horizontally around the corner? Oh, you mean carried while lying on the floor and not like propping it up. So, so what is the shortest length of L? Shouldn't like okay, I'm not really sure about this, but shouldn't L1 and L2 have the same ratio? It's 8 and 6. Because if you were to push this line, the that side, L2 would get bigger and bigger, and L1 would get smaller. Like if you how should I explain this? If it's like this, see L2 is really big and L1 is really small. This can pass through. This can pass through. This can't pass through. In order for it to pass through, I think L1, the ratio between L2, it has to be 8 and 6. Maybe? Think I will have to look at the answer. Wait. If I look at this line over here, it's like 8 and it's at here. Let me think. I'm tempted to look at the answer. A, V. I don't think this can be carried horizontally because if you can't push this any further because this is on the way. Mm. It is a 3, 2, 3. I need to find an equation relating L to 8 and 6. I want the answers to load. I clicked enter while the page loaded. Okay, let's think of this in a different way. Let's see. This is the longest item that can be carried horizontally around the corner. Can carry this around the corner. Can carry this around the corner. And can carry all this around the corner. Right. If you take a point, any point, and it reaches till here. It if you hold on, if you take this point and reaches this till there, can this go around the corner? Take the you take this, because what I'm thinking, whatever the length L is, if it can't reach L, finding the maximum length, right? Okay, so let's say it's at least 8. Bring it a little bit down. This is more than 8. Like L touches this wall and this corner, and this is longer than 8. But basically what I'm thinking, if you take a particular length L, oops, I don't want to erase the picture. If you take a particular length of L, stick it to the wall and the corner, then you keep pushing this point up while the length remains the same, and it touches this corner. Keep pushing it up. It's like this, and then you keep pushing it up. It's like this. I was thinking if it hits this wall, then it cannot turn. And then it gets stuck, I mean. And then let me explain it again. You have this line, take this point, push it up from here while this length is touching the corner, and keep pushing, and then eventually it will hit this line, and then you can no longer push it up. This cannot happen because of this. I have no clue. 3, 2, 3. Oh, it only shows the answer. It doesn't show the workout. Yeah, let me think. If I have a graph, whoops, this point 6 here, -8 here, I have a line. Uh, Actually, oops, -8 here. Eight. This is x is equal to -8. This is y is equal to 6. And I have a line. I have a line here. And the line changes, the gradient of the line changes. This is like y is equal to mx, and let's say m is the variable here, so m changes like different gradients. I have to find a particular gradient with the largest area, I think. Wait, let's try that. So y is equal to mx. I'm finding the area between 6 and -8. Uh, so y1 would be 6m. Nope. Let's call this 6 is equal to mx1, and then this point y2 is equal to -8m. And then the area is y2. Y2 could be negative, right? y2 plus 6. Wait, 6. So the area, so this particular area is times it by times it by 8 times it by half times it by 8 and whatever x1 is. I'm multiplying them. No, I'm adding 8 plus x 8 plus x1 and then over here 6 minus y2, minus because y2 would be negative. And in other words, area should be 6 half times 6 minus so plus 8m and then 8 plus 6 over m, like that. So I have to find a particular gradient. Also, I should open the scientific calculator. $48. I knew that. 48 plus 36 over m plus 64m plus 48. It's 48 plus 48. 96. 96 plus it with 64m plus 36m. And I want the derivative to be 0. Yeah. So I'm left with 64 plus yeah, squared. Wait, I'm getting a minus here. There is something wrong. Minus 64 But I'm getting a minus though. I shouldn't be getting a minus. Because I'm finding a change in area, right? So if the gradient changes, at some point it will, like the area will be like this. Let's see what's wrong here. Half times 6 minus y2. And then that's one value, that's this length. And then this length is 8 plus 6 over m. There's a mistake here somewhere. Maybe the half. I don't think the half matters. Maybe it does. I mean, I can take the half out, but I can like do this and then take the half out here. But I will still leave the negative over the other side. This is, by the way, wrong. This is wrong. Let me see what's wrong here. Should this be plus? Let me think. I don't understand what's the issue. It's 8 plus this x1. I'll just mark x1 here. X1, y2. X1 and y2. So 8 plus x1 6. Should this be minus though? Yeah, it should be minus y. No. Yeah, because y2 would be negative. Because if this line, if it stays on this point and this line goes in that direction, like it rotates and this line goes, if m, the gradient, keeps decreasing, then the area would become infinitely larger and larger and larger. I don't understand why I'm getting an error. 8 plus x1 and then 6 minus y2. So y2 is a negative number. What does 8m give? What if I reverse the entire thing? Make it like positive. Like if plus 8 was over here. Make it easier. 8. What I mean is, what if 6, 8. Now I need, now m is the variable. The gradient of this can change, but I need to find the shortest area. Like if the line rotates that side, all of this, the area would become longer. Basically the area would be like this. Not negative, wait. I mean like this. Need to find the shortest path. So over here, it's 6. Let's call this let's remove this. Let's call this y2, and let's call this x1. So then let's say 6 is equal to m times x1. So this is this point here. 6 and x1. And then this point here, y2 is equal to 8 m. Area is half times, this is 6. Y2 is negative, right? So 6 minus y2, and then 8, and x1 is negative. I should do minus x1. So area is 6 minus 8m minus 6 over m. $48. Plus 96 minus now if I want to find the derivative, wait, the dm, then this becomes square, this becomes 0, this, and then the m disappears. Then the half, so 36 over 64 root, and then all this. Wait, there was a shortcut to click through this, or maybe not. 0.75, 0.75. If this is 0.75, wait, hold on. Desmos calculator. Why is it 0.75? Why is it in that direction? It says 19.73 feet. That's the answer. 6 and 8. And then What is the length though? So I can figure out x1. This is 0.75, right? So 6 divided by 0.75 is 8. So I have 8 and 6 as one point. And the other point is 8 times 0.75. It's just 8 and 6 though. Divides 8 and 6. 8 and 6 square. Times 2. And then got 19.7. Not 73 though. 798. Because 8 plus 6 square plus 8 plus 6 square and square root all of that. No, wait. This is 8. This is shouldn't m be negative? Wait. Negative. So if that's the case, the first point is 6 divided. So the first point is negative 8. This is negative 8. First point, negative 8 and 6. Second point is what? This, right? Six and 8. I mean 8 and minus 6. So then 8 plus 8 and 8x, y, x, y. Let's do 8 plus 8, 16 square. Plus 6 plus 6 is 12 square, 400. Square root 400. That's not the answer though. Should I check online? Uh, Search. Wait, I just hope there are no arts here. It doesn't show any workout though. Okay, I will check this later. I don't know what the issue is. Uh, okay. Find a function that measures the total amount of time it takes to reach the drowning person as a function of the swim angle theta. For the following problems, consider a lifeguard at a circular pool with a diameter of 40 meters. He must reach someone who is drowning on the exact opposite side of the pool at position C. A lifeguard swims with a speed v and runs around the pool at speed. Uh, uh, the lifeguard swims at speed v and runs around the pool at speed w is equal to 3v. Find the function that measures the total amount of time it takes to reach the drowning person as a function of the swim angle theta. Okay, so lifeguard is here, drowning person is here. So runs, and then at B he jumps at the pool, right? Time X takes. Okay. So uh, speed is W is equal to 3v. Wait, before I do this, I want to see something. Okay, never mind. These questions are. I thought it would be easy for me, but I thought I would like breeze through this, but it's taking a lot of time. Uh, Circular pool A C B. Hmm. Runs around the pool. W is equal to 3v. Yeah, I have no idea how to do this as well. if the person was drowning, I think what they're asking, if the person was drowning at sea, the angle is theta. So at point A, the angle is theta. If the lifeguard was at B, how much time would it take to swim from B to C, given that the angle is theta? Speed is V, right? And so the time it takes at theta, basically, I have to find this dashed line. Where's the diameter? Diameter is 40. 40. So 40 meters here, theta here. And then this would be 90 degrees, right? And we can just use trigonometry. This is the hypotenuse. We need the opposite side. Sine theta is the opposite over hypotenuse. So what is 40 meters sine theta? And we want to measure it in time, right? So should it be V? No, no. Should be 40 sine theta. So the speed V is equal to distance and the time it would take. So basically, if I bring the opposite to the other side, it's 40 sine theta divided by V. That's the time it would take to swim to position C. Is that what they're asking? 2327. That's not what they're asking. Find a function that measures the total amount of time it takes to reach the drowning person. I don't understand what they're doing. Pi is in radians, right? So radians is how much of the radii you cover. Wait, is the lifeguard at position C or at position A? He must reach someone who's drowning on the exact opposite side of the pool at position C. So the lifeguard must reach at position C. I think it would be more, it would make more sense if they're asking, like, the person would be drowning here. if the person would be drowning here, lifeguard would be here. If he runs this much, then he swims. Then the answer would make sense. Because 40 pi is how much he's running. Like pi is the how much of the radius, how much of the radiance is how much of the circumference you cover in terms of the radius. So then this would be 40 pi, and the time it would take would be 40 pi over v. And when you're swimming, then this is 40. And then the time it would take here to here. This basically is cos theta, 40 cos theta. 40 cos theta over, this is w. This is 40 cos theta over v. The time it would take is 40 cos theta over v. But they frame it, here we must reach. This sounds like the person is drowning at position C. Okay, anyways. Which one should I do next? For the following exercise, consider limousine that gets at speed v. The chauffeur cost $15 an hour and gas is $3.5 a gallon. So let's do this. MV 120 minus 2V. So miles per gallon, that gets miles per gallon at speed v. Find the cost per mile at speed v. The cost at speed v. Wait, hold on, I'm getting a call. Sorry. I think it's a scam. Okay. Anyways, cost per mile at speed v. Cost per mile at speed v. The chauffeur cost $15 an hour and the gas is 3.5 per gallon. So the gas cost for 1 mile, no, the gas 120 minus 2V divided by 5 miles per gallon. And the gas is $3.5 per gallon. So if I reverse it, if I reverse it, 5, it cost these many gallons of to go 1 mile. So the total gas cost would be 5 times 3.5 for each gallon, right? These many dollars per mile. The chauffeur cost $15 an hour. The speed is V. Uh, the chauffeur costs $15 an hour. The speed is V. The cost per mile at speed V. I have no clue. The chauffeur cost $15 an hour. Find the cost per mile at speed V. Cost per mile. Hey, the chauffeur costs $15 an hour. The chauffeur part, this part is confusing me. $15 per hour. If this can go 120 minus 2v divided by 5 miles per gallon. If the speed was constantly at v, and these many gallons per mile, the chauffeur cost $15 an hour. I have no clue. 5 times 3.5 divided by 1. This is how much the gas cost per mile. Now I want to know how much the chauffeur cost per mile. If you go at speed v for 1 mile, uh, x miles per s seconds, speed v is, let's say, s is the number of time it takes, uh, s is the amount of time it takes to travel 1 mile at speed v. So v is equal to miles per second. Miles is 1. Speed is 1 mile per the time it takes to travel 1 mile divided by the time it takes to travel 1 mile. But I need wait. Why am I getting confused? V, I don't know the measurement of V. I think that's why. Is speed V per hour? I'm guessing it's per hour. Find the cost per mile at speed V. So I have to times this by 15. So 15 times this. So $15 per mile. Or 15V per mile. Uh, so in 1 mile at speed V, it goes S hours. It goes these many hours. So wait, if I do 1 over V, 1 over S. So in 1 mile, it will be 15 over V, right? I think that's the answer. 15 over V for 15 over S miles. 15 over S hours. Like, for this speed, this many hours, this ratios, given this ratio should stay the same. This ratio should stay the same. I think this is the answer. So the cost at speed V, this is probably wrong. 262.5. And then V is down there. So 120 V minus v square. So what do I need to find the cheapest? Driving speed. So I need to derive this, right? But how do I know if I'm on the right track? 331. I have an idea. 262.5. I'll just see it over here. 120v 120x minus 2x squared. I don't think this is the answer. If I do this and then I do this, what is this? 331. Approximately 34 miles per hour. But I don't think this is the answer though. Oops. What is this? Hmm. Wait. 15 over v. This is miles per hour. 15 over miles per hour. Or whatever the speed is. So the cost. Wait. Is 15v correct? Should it be like this? That would make sense. Cost is $15 per hour. Find the cost per mile. So I need to find the cost. It's $15 per hour. Wait, hold on. Okay, sorry. Where was I? Let's say V is V is 10 miles per hour. V is 10 miles per hour. Then for 10 miles, spend 1 hour, spend $15. If V is, wait, I have a calculator in front of me. V is 15, no, let's say 35 miles per hour. Then for 1 mile, the chauffeur cost 15 over 35, I think. Just 3 over 7. Hold on. Yeah, chauffeur cost for 1 mile, the chauffeur cost 15 over 35. So for 35 miles, the chauffeur cost 15, which would make sense. If the speed V is 65 miles per hour, then for 1 mile, it costs 15 divided by 65. So for 65 miles, it cost 15, which would make sense. So if it's going, V miles per hour, then for 1 mile, it's going to cost 15 over V, right? The chauffeur is going to cost 15 over V. This is how much the gas cost. It's chauffeur cost, whatever the speed is, 15 over V. So per mile. Okay, let's see now. And How should I do this? Yet I have a calculator in front of me. 5 times 3.5, 17.5. 17.5. Now what? The cost per mile at speed v is this much. Now cheapest. So when the derivative is 0. Yes, and then the times the derivative of the inside. It's minus 2. That's it with this becomes minus 15v like that. So this becomes minus 2 times 17.5, 35. And let's say this is 0. Wait, hold on. No, this is wrong. This is square. 15. Let's do this 35. This is a v square and 20 minus 2v square. So root, let's do it here. Root 15 over 35. Root 15 over 35. Wait, I think I have a better idea. I should do 35 over 15. This is equal to 120 over v minus 2. Nope, that's wrong. Square over v square. And then we can, since the whole thing is square, we can just do like this, 35, 15, and then 120 divided by this better be correct. 20 divided by plus 2. 34. Okay, that was the correct answer, finally. I've got one correct. Okay, okay, let's do this. My plan was to finish like 3 chapters. I can barely get past the exercise. Consider two non-negative numbers x and y such that x plus y is equal to 10. Maximize and minimize the quantity. So let's do the blue one. So 337. X times y. So maximize and minimize the quantity. Then minus y. Wait, I have an idea. Xy plus y squared equals to 10y, right? Is this the right path? Maximize and minimize the quantities. If I derivate this with respect to y, what happens then? If I derivate y and the derivative is 0. So then derivative of 10y minus y square. This is equal to 10 minus 2y. Y would be equal to 5. So y and x are both 5. Hold on. 337. So maximum it's 5. This is lacking. What about minimum though? Wouldn't it be 10 and 0? Because if I can separate it like this. Why don't I get 10 and 0? Yeah. I did not look at. Okay, never mind. 10 and 0. How would I get 10 and 0 like algebraically? 3, 3. Okay, I don't want to do this. Let's go next. I wanted to do more, but never mind then. It's going to take forever. In this section, we examine a powerful tool for evaluating limits. This tool, known as L'Hopital's rule, uses derivatives to calculate limits. With this rule, we will be able to evaluate many limits we have not been able to determine. L'Hopital's rule can be used to evaluate limits involving the quotient of two functions. Consider limit as x approaches a, f of x over g of x. If the limit of f of x as x approaches a is L1, and the limit of gx is L2, and they're both not zero, then the limit of the division is L1 divided by L2. However, what happens if limit as f of x approaches limit of f of x as x approaches a is 0 and limit of g of x as x approaches a is 0? We call this one of the indeterminate forms. How do you pronounce? Of type 0, 0. Of type 0 over 0.
Indeterminate. Indeterminate.
Indeterminate. Okay. This is considered an indeterminate form because we cannot determine the exact behavior of f of x over g of x as x approaches a without further analysis. We have seen examples of this earlier in the text. The idea behind L'Hopital's rule can be explained using local linear approximations. Consider two differential functions f and g such that f of x as x approaches a is 0 and g of x as x approaches a is also 0, and such that the derivative of g at a is not 0. For x near a, we can write f of a x is approximately equal to f of a plus derivative of f at a times x minus a, and the same thing for g of x. Therefore, we can divide them. Since f is differentiable at a, f is continuous at a, therefore f of a is 0. Similarly, g of a is 0. If we assume that the derivative of f and g are continuous at x is equal to a, then derivative of f at a and derivative of f at a is equal to the limit of f, the limit of derivative of f of x as x approaches a. Using these ideas, we conclude okay, the f of a is 0, g of a is 0. Okay, that makes sense. Note that the assumption the derivative of f and derivative of g are continuous at a, and derivative of g of a is not equal to 0 can be loosened. So for the 0 over 0 case, if you want to find this, you can find the derivative. Assuming that the limit on the right exists or is infinity or negative infinity. Applying L'Hopital's rule. I'll just, I think there's a lot about this infinity, negative infinity. Okay, I will do, I'll read some more and then I'll end the stream. So, evaluate the following limits. A limit. Let's do B first. B. X approaches A. Then but the derivative has to be with respect to x, right? Sine, derivative of sine is cos pi x, and then the derivative of the inside. Ln of x is 1 over x. And now what? So this, you do limit as x approaches 1. But then the x goes here, but x is approaching 1, so I don't know. So cos pi is negative 1, so this would be negative pi, right? Yeah, negative pi. L'Hopital's rule, infinity over infinity case. Suppose f and g are differentiable functions over an open interval containing a except possibly at a. Suppose limit of f of x as x approaches a is infinity or negative infinity, and limit of g of x as x approaches a is infinity or negative infinity. Then we have this case. But why does it work for infinity though? This. So this is this. F of A and G of A doesn't exist, right? Except possibly at A. This argument won't work because it's like this proof won't work if it's for infinity over infinity. The first one should be 3 over 2, right? The next one is 0. What's the ln of x is 1 over x? What is minus cosecant square x? Derivative here. Like we can just apply the limit normally, right? Like just like plug in 1. So 1 plus 5 is 4, and on the bottom 3 plus 4 is 7. 2x3. Oh, it has to be 0 over 0 case or infinity over infinity case. Other indeterminate form. Okay, I think I will read about this next stream because I have to go. So I'll read more about the indeterminate form because I need proof about the infinity or infinity thingy. And see you guys next stream.